Today's date is 9/18/18, okay? So, first of all, polynomials. We talked about those yesterday. Let's say it again. It has many terms with whole number exponents. Right? And then if it's a polynomial function, it's just going to be a graph. It's just going to be a graph of a polynomial. Sorry, it's so sloppy. Hey, what we saw when we graphed them is they're curvy, aren't they? You guys agree? Polynomials are curvy. Here's an x squared equation. Here's an x cubed, right? Here's another x cubed. Here's an x to the fourth, right? Here's an x to the fifth. So polynomials are curvy, right? They're always going to be curvy because they're constantly changing which way they go, okay? Now, end behavior is either off to infinity or to negative infinity, okay? So our end behavior is either off to infinity or off to negative infinity, okay? So if I take a look at my previous examples, this one's heading off to infinity. As x approaches infinity, the y approaches infinity because the y's are going up, right? This one's different because as x goes this way, as x approaches negative infinity, the y goes up to positive infinity. That's my end behavior, right? So which way is it going, right? Look at this one. So it's going off to infinity, but this part's going down to negative infinity, right? End behavior, where's it going in the end? It's easy, right? This one's going off to positive infinity, and this one's going off to negative infinity, right? It's just the end behavior. Where's it going in the end? This one's going off to positive infinity, and so is this at the end. They're both going off to positive infinity, okay? Heading off to positive infinity and heading off to negative infinity, okay? So our end behavior is talking about at the end as it approaches infinity, okay? So the book likes to write it like this, okay? It's kind of a weird way to look at it, but it's saying, remember, y and f of x are the same thing, okay? It's saying as x, and I want everybody for a minute just watch my hand. Watch my pen, okay? Everybody watch my... So as my x values go this way and get bigger and bigger, the graph's going up, right? I'll do it again. Watch. As my x values go this way and get bigger and bigger and bigger, my y values are going up. That's what this says. X approaches positive infinity, so does y. Watch my pen again. Don't write anything. Watch. As my x values go this way or to negative infinity, my y values go down to negative infinity. That's what it's trying to describe, okay? Let's look at one more, okay? As my, watch my pen. Watch my pen. As x gets bigger and bigger and bigger and bigger, as x gets bigger, what does the y do? It goes down to negative infinity. See that? Tim? Yeah. As x goes and gets more and more negative, x is getting more and more negative, what does y do? It goes to positive infinity, doesn't it? It's a little bit tricky, okay? Thumbs up on that? We'll keep practicing this. Okay, so, first of all, we talked a little bit about this yesterday, about these, right? We did a little bit of these, but what I want us to do real quickly is first, number one, is that a polynomial? Just go, Tim. Oh, is the pass not here? Where's the pass? Oh, you gotta wait. Okay. So, yes or no, is it a polynomial? How do we know it's a polynomial?
Because it has more than 3 nominals.
Well, what do the exponents look like? What are the exponents? Aren't they all whole numbers? Well, it's not in the right order. This thing needs to be rewritten. I'm going to rewrite it. Rewrite it. So let's rewrite it in order. So this is my biggest term because it's x to the fourth. Not because of the 3. The 6 is bigger, but so you rewrite it in order. So I'm going to go, all right, f of x should be a negative 3x to the fourth. Put your biggest term first, right? And then what's next? What's the next biggest after that? My 2x squared, right? Plus my 2x squared, then plus my 6x plus 1. Okay, that's standard form. You put your biggest exponent first. You put your biggest exponent and then your next biggest and then all the way down. But it goes by the exponents, okay? Now, we would say this is degree 4. We're going to say it's degree 4 because the degree deals with what is the biggest exponent. Degree 4, okay? The leading coefficient is the number in front. So the leading coefficient is the number in the very front. It's leading the charge, so it's leading the negative 3. Okay, let's go through this again. Okay, so a polynomial has to have whole number exponents. Got it. Whole numbers, right? Those are all whole number exponents, okay? We got to put it in order. X to the 4th goes first. Then the next biggest, which is an x squared. Then the next biggest, That puts it in standard form. Then, what's the degree? The degree is the biggest exponent. It's degree 4. The leading coefficient's the number in the front. When we rewrite it, we got to rewrite it. The negative 3 is leading the charge. That's my leading coefficient. Okay. Thumbs up. Okay. Let's take a look at 4. Okay. So what goes first on 4? Number 4. What goes first? Okay. I think the negative 2x squared goes first. You guys agree with that? So p of x equals negative 2x squared. Why does the negative 2x squared go first? Biggest exponent. Good answer. What goes next? Plus 3x, and then last is minus 2 squared root of 3. Good. Easy, right? What's the degree?
2.
2 is correct. It's the biggest exponent. What's my leading coefficient? Yep. Easy, isn't it? Leading coefficient is negative 2. Thumbs up. You guys agree? In order, it's the biggest exponent down, all the way down. The degree is that biggest exponent. And then finally, the leading coefficient is the number in front, okay? Now, evaluate. Well, I want to do this one. I want you to do this one. So we're going to do h of 2, okay? It's so easy if you just do it my way. Let the calculator do the work, okay? Be a believer. Let the calculator do the work. So what I would do is go negative. I'll put the 2 cubed minus 2 times the 2 squared minus 3 times the 2 plus the 4. Okay, so we're going to plug it in. Good. Now, if you want to do this by hand, you go ahead. But me, I don't know, call me lazy. Say what you want. I'm just going to let the calculator do it. I'm going to go like this. I'm going to go negative parentheses. So I'm going to plug it in, right? Negative, and I'm going to put my 2 to the 3rd power, okay? Subtract 2 to the 2, plug it in 2 squared. See what I'm doing? Subtract 3, plug in my 2, plus 4. Let the calculator do the whole thing for you. Just put it in the calculator, push, boom, enter. There's my answer, negative 18. Negative 18. So what this is a point. This is a point at 2, negative 18. But there's my answer right there, okay? Easy? I just plugged in 2. Am I doing okay? All right, let's look at 7. Okay, there's 2 ways to do number 7. One is the easy way and one's the hard way. You want to do it the easy way? Okay, because this is negative at the end to negative 3x, it's going to fall at the very end. No matter what, up and down, up and down, up at the end. At the very end, it is going to go to negative infinity, okay? So describe NBA. How do I know that? We could graph it, but I do know that as x approaches infinity, f of x will approach negative infinity, okay? And because this is even, it's going to go up at the end too. Okay, so as x approaches negative infinity, f of x will also approach infinity, okay? Okay, real quick, watch. I got a picture for you, okay? Check it out. Even exponent, right? Goes up at the end, goes up at the end, because even exponent, okay? Odd exponent, goes up, goes down, right? Do you see a pattern? Okay, check it out. Odd goes up at the end, then goes down, right? Check it out. Even. If it goes up in the end, it's going to go up in the end, right? See how that works? So if it's even, it's always going to fall the same direction as the end, okay? Odd, right? Goes up the end, but then it comes down at this end, right? Because it's odd, okay? All right. Number 9. We don't even have an equation, but what do you know? Do you know what kind of graph this would be? Just a guess. It's a x cubed. How do I know it's an x cubed? Sure looks a lot like that one there, doesn't it, right? Except for it's going downhill. So this is a negative x cubed. Because it's going downhill at the end, right? Okay, that's all I have for you guys. Let me go ahead and stop the recording. With a little luck, it will record for me, okay?